Today I'm going to be talking about, I think, exciting things, not only for me, because I'm working on these things, but also on the things that most of the people are exciting these days. We'll be talking about Kafka, Kubernetes, and more deep dive into streaming platform, what is it, so far and so on. Yep. So, how many of you guys using Kubernetes in production these days? How many of you guys using Kafka in Kubernetes in production these days? How many of you guys want to use Kafka in production? Okay, this is my people, right? Okay, so this is how I like to call these people, the people in the DevOps world, and they supporting Kafka and all sorts of streaming platforms. So let's get to it. There's a thing called like a conference-driven development. When you go to conference, meeting people, you get excited, or like a book-driven development. You was reading the book, you get excited, and you came to your boss and saying, "Hey, there's a cool thing called Kubernetes. Let's get to it. Let's invest everything on it. Everyone is doing this. It's cool stuff from Google. People from Google develop this, and after that, they start going to different places. The Kelsey Hightower was one of the writers of this book. The Ben Joe Bida, he started Heptio, and the Brandon Burns, he went to Microsoft to work on Azure and the Kubernetes in Azure. And you're like, yeah, that's cool stuff. And the Kelsey Hightower, it's pretty awesome dude. And you start following him on Twitter. If you don't, you should. And yeah, your boss said, yeah, let's do it. Let's do this Kubernetes thing. Yeah, so just put everything on it. So let's do it. And after that, you was approved this, and after that you go to Twitter, Kelsey Hightower reading this tweet that's saying that, yeah, the Kubernetes is cool, but there's a thing of stateless workload and the stateful workload, and with stateful workload, there's a thing called complexity, and I personally not feel like Kelsey personally prefer not to run this, and you're thinking, shit, what I need to do, like. Specifically, Kafka, Rabbit, and Postgres, and other things on the static infrastructure and static infrastructure, and let Kubernetes alone, right? How frustrating is this? Like, you just convince your boss that we need to get on board with this Kubernetes thing, and now, like, one of the founding fathers and the chief evangelist of Kubernetes telling you that maybe running stateful workloads is not a good idea. But don't despair. I'm here to help, and this is, you cannot talk about Kafka and Kubernetes without quoting Kelsey Hightower or without quoting Franz Kafka. So I fulfill both things, and hopefully from the next 40 minutes, I'll try to explain this. There's no need to be that upset about this like Kelsey did. So I will walk you through our journey, what we did in our company. We're running a largest cloud of the Kafka, managed Kafka servers, and the things what we learn, and the things that I learned when I was working with customers. And the customers, don't hesitate. This is my Twitter handle, Oracle Code 1 Twitter handle. I want to say hello to all people in the internet who are watching us live right now. That's awesome. You can all read about this, and let's get to it. So before, I need to explain the basics, right? So I need to explain where the things are coming from, why things are relevant, or certain things relevant, certain things are not. So, and I would like to start a little bit about Kafka. I saw a few hands that show that they know Kafka, or at least like they're running Kafka. But let's do it again. Like, how many of you guys running Kafka, or know Kafka, or tried Kafka at all? Okay, so we have a good understanding. I will point out some of the bits that usually missing from the intermediate to the advanced level. So essentially, every organization is built on top of idea of data flows, but essentially in every organization, we're building data silos. We're building databases, we're building ERP systems. Everything is interconnected, very difficult to find where things are. And this is how the LinkedIn looked like before Kafka was invented, and this is how LinkedIn looked like when Kafka was invented. I'm just kidding. But idea is the same. The Kafka was invented in LinkedIn in order to provide the ways how to speed up ingest into the Hadoop cluster. And the sources were different sources. Things coming from the files, from different web services, databases, data warehouses, and there was no common interface. And the Kafka and the inception of Kafka basically allows these data streams to be ingested in a uniform way. And these days, Kafka is powered multiple use cases around the world. Integration about the databases, moving data from change data capture events from Oracle into NoSQL, like MongoDB or Cassandra, the offloading data from mainframe systems into and allow to use this data in the different places. Kafka used one of the most useful or used use case was like log aggregation. Maybe like if you ask people what you do Kafka for like 4 or 5 years ago, maybe like 4 years ago or 3 years ago, they used the Kafka to stream logs. Now Kafka is an integral part or even backbone for microservices, where they organize interconnection or interchange between different components in this microservices world. Now, but in terms of like high-level architecture, the Kafka is obviously a main component. Kafka provides ability to have distributed, highly scalable, log-based data structure that will store your information or your stream of facts. So, but technically, let's go a little bit deeper in technicalities here. In the Kafka itself, it's a distributed system that depends on another distributed system called Apache Zookeeper. And Apache Zookeeper is the integral part that stores some of the metadata for Kafka or allows to do a literal action for some of the internal mechanism that runs inside of Kafka. And the interesting fact that, how you can tell that you're talking about some big data tool. If you have a Apache Zookeeper as your dependency, you're talking about big data tool, right? So we're good here. But sometimes it's not enough. Sometimes it's not enough. And Kafka knows how to, there's the clients that allow to write data, read data from in out of Kafka. But there's something called Schema. And usually Kafka don't really care what you put in there. You're putting some binary payload, you're putting some information like bits and bytes. Kafka don't care. However, in your organization, when you run at scale and we will try to create like the microservices backbone across multiple applications, you need to have the common language. You need to have common vocabulary of things, like defining what kind of messages we're going, what kind of messages we're sending, how this message looks like. And the Schema registry actually provides the way how to store this information. And it integrates with Kafka clients. So when you're reading data from Kafka, and Kafka say, hey, looks like this thing has a schema ID, so let's pull this schema. And also, we would know how to deserialize it back. So with the Schema registry, also another benefit is that you're reducing your size of your payload. Essentially, you don't need to put in or like embed schema to every message. You just send raw data, and the schema would be stored somewhere else. Now, Kafka also has batteries included. So in order to process streaming data, you need to have a stream processing framework. How many of you guys using any like Spark, Flink type of frameworks to process streams? Yeah, a few of those. So, but Kafka Streams, it's a Java library that allows to build applications, just focus on one simple goal, is to write stream processing capabilities. You don't need to write clusters, submitting jobs, run this in distributed mode. This library provides all bits and bytes in order to achieve this goal for higher scalability stream processing needs. Now, in organizational world, there is some legacy application, there is some database application. You don't want to write producer or consumer, the client for each and every application. So you can get on board with a thing called Kafka Connect, which is a framework for building data connectors. So you can plug and play different things. There's the connector for Oracle that allows to listen the Golden Gate replication events and stream this data into Kafka. There are connectors that allows to listen this event and offload this into any other source like Elastic or Redis or any type of database. Or you can do like stream processing of this data as derived and after that send it somewhere. Next thing here is obviously many languages Kafka becomes so popular that many languages have a native support for Kafka clients. But there's some cases where you need to deal with languages that don't have native client. Bash, for example. How you would you like to send some messages from Bash, from curl to Kafka? And with REST proxy, it provides you a REST interface where you can write data into Kafka and read data into Kafka. So and there are a lot of things that happen in this the streaming architecture. So you see the complexity of the things, and some of the elements are optional, but there's bare minimum of elements that you need to deal with when you're starting your Kafka journey. So usually people, when we're talking about Kafka and for operations, we're talking about how to run, how to deploy brokers, how to provide a reliable way to store information about topics and partitions at Zookeeper, consensus, and so far and so on. Real quick about architecture of the producer and consumer. So Kafka is distributed system. So Kafka is highly dependent on the network. So communication between clients and brokers happens through the network. Kafka has capabilities of in NoSQL database where the producer and consumer publish data into partitions, and based on the key, producer know on which node write to this particular partition. And different partitions live on the different machines, and you run your Kafka cluster at scale. Now, for consumers, you can also have consumers that can listen this. You can subscribe to a particular topic and read the messages from the topic. Kafka is designed to be heavily accessible on reads, so it's okay to have a bigger number of consumers. And the interesting point here that how the Kafka is different from many other messaging systems, for example, even though you can push to the consumer, Kafka is not like removing messages once you read this. So you can reread the message over and over again to come up with like different use case. You change the algorithm of like stream processing. You want to replay the events, which makes it like a very good candidate. I'm not saying ideal candidate yet, but like very good candidate for things like event sourcing and storing information for microservices where you need to like replay of history of events and like a ledger type of use case. Kafka internally is distributed system, and lots of things going on between the brokers. So network communication and the network latency is essential, like low network latency is essential in order to replication protocol to work. Replication protocol exists in order to survive some of the failures of individual node, survive of the failures of the producer and consumers. So when you publish message for individual topic, topic usually have a replication factor, and you can replicate and create multiple copies. So in case of failures, or one of the replicas will take over responsibility of serving the data. Now, we've all done with Kafka. This is bare minimum that you need to understand, even though you never used Kafka before. So a couple things that need to remember. Kafka is dependent on network, and Kafka is dependent on storage. Kafka provides persistency, provides you with the way how data would be stored. And the persistency can be achieved in multiple ways, either storing on disk, and when the node will go down, it will reread this topic information from the disk. Or if it's like started and empty, it can replicate the data from another node. So this is the basics of the Kafka. Now Kafka expert here, we can go and move further to become Kubernetes experts. Now, I was thinking about like evolution of the different tools, how we deploy it. Like when we start 10 years ago, like 15 years ago, there's one large app, the multiple people working on this one large app, monolithical app that existed, and after time to time, people become very hesitant to touch and introduce new changes because some changes can break the things that you not expect because it's a huge, maybe not very properly unit tested, things like that. So organizational-wise, people start breaking the silos. They start communicating with each other. Hey, like a DevOps world, right? So we can start we start throwing the things over the fence to the people who, like developers, we develop things, and now, okay, so operations people go support this. Now we're more in a DevOps world where we communicate with people, we start building microservices, we start building smaller teams, we start building pizza-sized teams, right? It's, what's the pizza-sized team? People can eat one box of pizza. Basically, like I can eat one box of pizza myself, so I consider myself as a one box of pizza-sized team. So now we start building microservices. Microservices was good. Now we start thinking about how to deploy this, how to move this from point A from point the development to the point production, because every developer wants to be in production. Production is the sweet place in our lives, right? So we're on board with the containers. Containers provide a way to isolate things and distribute things. So this inception and liberation of containerization technologies allows us not only differently look how we package software, but how we collaborate with other people. So instead of sending some build script, or instead of sending some packages of software, zip file, you can send the Docker image, Docker file, or you can send Docker Compose if you have multiple elements there, multiple components, and the people can start on their machine the same way as you started this on your machine. And which brings us to another brave new world. So how we can manage this, and which brings us to idea of orchestration, of management of controllers, not controllers, management of containers, yes. Management of containers, so how to manage life cycle, how to make sure that our containers are healthy, and something happen, who will restart this? Like the Kubernetes actually allows us to do things. And in 2014, we started with microservices to solve problems with the monoliths. In 2016, we introduced Docker to solve problems with microservices, and now we're all about the Kubernetes things to solve other problems. So Kubernetes will be, hopefully, and maybe in 2020 we will introduce some new technology that allows us to solve problems with Kubernetes. I don't know, maybe. All right, so now we're in containerized world. Software in containers is good. We can write our Java application, we can write our Go application, and it really doesn't matter from perspective of container runtime, like what kind of application runs inside, right? It can be like your microservice, it can be written on any language, and from perspective of the platform that runs these containers, everything looks like, just generic container. So generic building blocks and the generic approach to the things which makes the Kubernetes so powerful, and it has certain ways how you can navigate or package your software in order to work it with Kubernetes. And as orchestration layer, it handles allocate resources for computation. So it will allocate resources for a container to run, provides a network to communicate, provide a storage if you're running stateful applications, and some applications will require storing state somewhere, right? The microservice itself, it may be just a simple web app, but this web app needs to get the data somewhere. Database, messaging system, like Kafka, Sunfire, and so on. These systems will require storage, right? And obviously, when you're running in the orchestration mode, you don't really know who's your neighbor, and you don't really know where you're running, so the services can out how you can inject some of the information about other services. It's also important, like how the Kafka would know where Zookeeper is. So it's also important. So Kubernetes allows to allocate and schedule resources. Different resources. Kubernetes operates with the concept of resources, and different resources available there: pods, maps, secrets, deployments, stateful sets, replication, replica sets, etc. Kubernetes provides the way how the different components can communicate. So networking, and this mechanism is pluggable. There are different plugins that allow to differently communicate between pods. Like some plugins allow to seamlessly communicate like isolated networks, like some physical networks, like your Kubernetes cluster will be part of actual the organizational network, so far so on. Lots of things and lots of flexibility available. Storage storage mechanism allow you to store data in declarative way. You don't need to basically think, because there's different storage classes and you run in the cloud. There's APIs that allow to communicate different underlying systems to provide the storage. So you can ask for storage and you will get the storage, and you don't really care where it came from. But from essence, like Kubernetes itself, it's just a API server that you communicate through some tools like kubectl. This is the tools how we communicate, how the operator, how the operational people communicate with Kubernetes, deploy things and get information from things. So the kubectl is essence. It needs to stay. We don't want to introduce new tools in order to manage software, because kubectl is awesome. And kubectl uses the API calls to Kubernetes cluster, and Kubernetes cluster will receive this message. We'll check the state of the cluster. We'll check this command, and after that, make things happen. When you send a command, you're saying, I want my world look like my world is 4 nodes, my pod's running on 4 nodes, and Kubernetes will make it happen. Idea of pods, it's very interesting. Like when you start learning Kubernetes, you start thinking, okay, so why they doing this? Like why it is so much important to have multiple containers? Why you need to group? Like have you ever need more one container inside a pod? And apparently for many complex use cases, you actually, and it's a good thing to have multiple containers inside the pod, because there's interesting idea that if you have a multiple containers inside the pod, they share local host, that you don't need to have sufficient network to communicate, and you don't need to some like attached volumes because they're sharing file system. And you think about this, okay, so like you have some legacy software that you package in a container, but here's the thing, you lost the source, and this application only communicates only with localhost, and you thinking how I can move this in a container, because like a localhost, it doesn't mean anything to me. And apparently with the patterns called like ambassador or a sidecar container, you can actually allows to this like a legacy application, you lost the code and that interacts with your local host, can expose this functionality. For example, like there's an application that requires some weather, and it depended on some like a weather server on the local host. Now you can have an ambassador container that will listen to particular port that this guy will be interested in, and after that will go outside and bring the data in. And the sidecar container, it's the opposite. So you can expose some of the information that developer of this particular container was not intended to expose. For example, metrics. How you would do metrics in Kubernetes, in Java, you know that like a JMX, but how you would like expose this, so for that matter, you have a sidecar container that reads JMX and exposes the rest to outside world. So that's cool. Storage. This is like integral part for the systems that require storage, and that requires saving state somewhere. And Kubernetes has this a concept of persistent volumes. Persistent volumes is actually some device that you're requesting, and it would be a pool of resources that you can reuse. And there's persistent volume claim. It's kind of like application. You coming to the register saying, dear Sir Kubernetes, I want to have 500 gigabytes of storage. And the Kubernetes says, yes, here you go. And this is how the persistent volume claim works, basically. Or if there's not enough resources, Kubernetes says, oh, sorry, dear sir, I cannot fulfill your persistent volume claim, so you will not get this resource. With this concept of persistent volumes, different storage that can be used inside the Kubernetes has a storage class. When you're submitting this claim, you specify kind of storage class, and the Kubernetes cluster will make sure to create required persistent volumes. When you deploy your workload, you will be requesting this information. So far so good, right? So just a quick recap of the things. We have a Kafka. Kafka requires some of the things to run in Kubernetes. Each and every individual Kafka broker will be run inside the pod. Zookeeper container will run its own pod. Now, we building up to some of the things that will require us to run this in the complex setting. So Kubernetes, this is what the thing that the Kelsey was talking about. The Kubernetes provides some of the primitives that allows you to build things from the low-level primitives. And one of the primitives that we will be using, or like the foundational piece for running stateful thought, is stateful set. So the idea of the stateful set, again, most important facts. One, it provides you with stateful network identity. When you start some of the pod inside the Kubernetes, it will get some random name, like you have a my pod, blah, 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 and after that, AF, boom, boom, 01, something. Not very friendly, not very useful in order to, if your system requires like stateful URL. So when you are creating your pod as a part of a stateful set, you will network identity saying like my Kafka-0 or my Kafka-1. So in this case, this identity will stay and it will be preserved between restarts of the pods, because pods, can die. Another thing is that stateful sets provide stateful network identity and provides stateful disk identity. So when your pod will die and will be rescheduled, Kubernetes will make sure it will attach to the same storage that it was before. So it's very important for the systems like, because it depends on disk, it depends on the file system, and it requires that same folder will be attached, because like a server ID will be stored there, so far so on. So it is also a very important piece. We'll deploy this. What are you guys doing YAML for your deployment? Like YAML is awesome, right? No, YAML is crazy, right? So what happens with the people in operations? We're writing shell scripts, bash scripts, some of the logic, and now we need to write YAML, right? So how ridiculous is that? But here's the thing, right? YAML is a declarative approach for describing how you want the state of the world will look like from Kubernetes perspective. So people for a very long time use like kubectl and passing YAML there. If you change something, you send YAML, updating, send YAML, and something like that. Things slightly changed for good with introduction of Helm and the concept of a Helm chart. So Helm charts is a glorified YAML that has, templates. Now, so instead of doing this like a yourself, you're writing like a set commands to, replacing some of the things. You still kind of like a programming in Bash and you program in YAML. Now you have a Helm where you can put different parts of your customization logic. For example, you want to say, okay, version 5 of this image needs to be deployed with release 1. And Kubernetes doesn't know anything about releases, but Helm provides you with this concept of release, so you can manage, you can have version, you can customize it, and it has two components. One, the server-side component we call, and you have a communicates with the tiller. So you have your YAML files, your templates will join this. You turn this into something that your tiller can consume, and you're good to go. But here's a silver lining for you. Like if you hate writing YAML and you thought that your life was miserable enough, the Helm 3 will change everything. So now it will not use the server-side component, and you don't need to write YAML. Hey, you need to write Lua. Okay, So I recorded a video where it explains every bits and bytes you don't have to take a picture, because at the end would be a very important slide with all links, so you can go there. Anyway, yeah, I explain like all this without like hand waving, but I actually drawing things on the whiteboard that explain how things works with Helm. Now, we explained multiple basic components. We talk about persistent volumes. We're talking about some of the networking. We talk about stateful sets. We're talking about pods. But when basic components are not enough. So you think about this. Yeah, I have a generic application, and I can probably make it work for me. But what about some of the complex software that will require some tender love and care? how many of you guys have like specific like a DBA in your team who manages like your database or like manages your NoSQL database? Do we have like specialists, that kind of specialists in the rooms, right? So we have people who has domain knowledge about certain components. You cannot just say, hey, we have a generic DBA who knows everything, and we kind of find a way how this guy can deploy and Oracle and MySQL and Postgres and Cassandra and the MongoDB and the CockroachDB or whatever, right? So there are some basic concepts they can use. Yeah, there's like a network listener that they need to, there's some disk that they need to allocate for storing this data. But in order to support this in production, you need to have domain knowledge about how to restart your Mongo in case of you doing like rolling upgrades, how you start your Kafka in case you're doing rolling upgrades, and so far and so on. So this is why there is no way how you can like program this logic in YAML, right? So in this case, like for example, I will give you just a quick a cooking list or checklist of the things what you need to do if you deploy in Kafka and Kubernetes these days. So let's start with Zookeeper. So to deploy Zookeeper, we need to have a storage where Zookeeper will have these files. We need to create the stateful set with like minimum number of 3 nodes because, yeah, distributed system, you need to start minimum of 3. Now, you need to also think about how your pod will communicate with other pods. So you need to configure anti-affinity rules in order to Zookeeper will land on the node where there's no other Zookeeper, because you don't want to lose two Zookeepers at a time when node will go down. So you need to configure anti-affinity things. Now you need to expose Zookeeper communication. Now you need to create the config maps in order to expose the metrics. But this is just the beginning. You need to have same thing for Kafka. And now you need to get this URL for Zookeeper service. And so far, so on and so on. So a lot of interesting things that you need. So as a first step, you can say, so let's do Helm. Like Helm allows us to like a program and allows us to template certain things, so we can actually replace the certain things, because we don't need to like there's like stateful sets. We can like replay the same thing with stateful sets. We can change like directory names for these things. We can reuse some of the things. Yeah. So let's see some YAML. Who's up to this? YAML. So the cool thing about Helm is that it allows you to hide certain bits and bytes by this component called chart. So with the Helm, you're operating with charts. And when you want to deploy something, you say, hey, deploy this chart. So I have a CP Kafka. I want to deploy Kafka. But if you look inside this chart, you will see all the things I just mentioned. So let's look at Zookeeper first, because I started with Zookeeper. So I started with Zookeeper. There's my stateful sets that has everything. So it has anti-affinity configuration, has some of the JMX configuration, all the things. But as you see here, there's also template. The places where you actually put your customization logic. And if you go this file, like a magic file, values, this is only file that you're actually changing. So you're saying, hey, in case of I want to do upgrade, I just need to change this image tag. And in order to, I don't need to go and change this in my YAML file and do like this update. Helm can handle this for you in order to track your changes that you do in this file. But Helm don't know anything about what it runs. It doesn't know how to properly shut down Kafka in order to upgrade certain components. So for example, when we need to do rolling upgrade, we need to know that there's a component inside the Kafka cluster called controller, and the controller itself needs to go down last, because to initiate the controller it takes longer time rather comparing to the time how you initiate the regular broker. So far and so on. This knowledge knows some of the dev Kafka ops person in your organization, and this is how we end up into operator. So we build up all this drama to the point where you can actually automate some of the steps or automate some of the domain knowledge of individual person of dev Kafka op into this concept of operator. So the term itself. It was very popularized by CoreOS people who also develop like for building operators, but essentially they trying to establish this kind of mental connection between the person who is responsible for running things for you with this piece of software that runs inside the Kubernetes, has some additional domain knowledge about certain things. So in particular case, this operator for knows how to scale down, how to do rebalancing of the data, how to provide the health checks, and how to expose these metrics. And it's also built up on top of Kubernetes component called controller. So basically, you have some piece of code that's written on any language you like, because it runs inside container, and you don't really care, but it interacts with Kubernetes API and handles certain events that happen with particular resource. You have resource Kafka. Hey, I want to have 5 Kafkas. In this case, controller will listen to the resource and make it happen inside a Kubernetes cluster. Custom resource definition allows you extend Kubernetes API. So you not only with stateful sets, pods, but you can have domain-specific components runs inside Kubernetes. For example, I want to do kubectl get Kafka, and I would know how Kafka clusters I run inside Kubernetes. So let's see what the operator does and how it looks like. So first of all, I have my Kubernetes cluster running right now, and I already have the operator deployed. As you can see, operator is just one of the pods that runs inside your Kubernetes cluster, and it just will be listening some of the events. Let's do Kafka. Let me find this command. And your knowledge about Helm also not going away anywhere, because you also leverage it as a generic tool. And let me deploy first, and after that I will talk about let's do Zookeeper. I will do Zookeeper, and I will show you what exactly I'm running. So I'm enabling Zookeeper. It will start Zookeeper. We should see some Zookeeper instances coming up here. And I do Kafka enable. So let's see. So in this case, I'm enabling Kafka. I want to start Kafka with replica 3, and we will look code in just a moment. So we will leave this guy for a while. So it will run all the things. It will start the containers, and I will walk you through some of the things that I have. So remember this picture. In this picture, most important, or this picture, in this code, most important thing was values, right? So in the values, you actually have your domain kind of knowledge about things. So with the operator, your YAML file, it's not going anywhere, but it will look more concise. In this case, you're not operating with this low-level concept of stateful sets, persisting volumes, but rather you operating with the concepts like, Zookeeper or Kafka. So in this case, this is what you're actually submitting to your. This is actually what you're submitting to your cluster, and your controller will make things happen. So if I would use tool like kubectl, I will do kubectl get Kafka. Hey, now I have kubectl, and I see the things called Kafka. I will do Kafka -o. So I'm output the content of this in YAML, and we'll pipe for some pretty color. Yeah, so this is how my resource that now called Kafka cluster. So I'm not operating with low-level concepts anymore. I'm operating on a high level because I don't care about underlying concepts. I need to run Kafka cluster. So in this case, I see this is my Kafka cluster. Helm provides me ability to track release, so I know from what release it came from. So from my CI/CD pipeline, I know what was changed, so I can track the changes. This is what kind of image it uses, how many resources it has here, and so far and so on. In what zone it runs, and all these cool things. If I do describe, it also, as you can see, I'm just using generic tools. I'm not using any specific to Kafka tools. As an operator, the system administrator that runs these Kubernetes things. it's important because I don't need to use, I need to learn new things. And also the standard tools like described allows me to get the status. For in this particular case, it says, oh, it's missing Zookeeper's dependency. Why? Because Zookeeper is still coming up. Let's see what's the status of my Zookeeper. So I can do get Zookeeper. So I will see the list of Zookeepers, right? And in this case, Zookeeper will give me Zookeeper. I will do describe. In this case, I will see what is going on with my Zookeeper. The cool thing is that Zookeeper already established. So the Kafka pods, they were in the back-off mode, so they will just catch up. One of the things that the operator does for you, it's like automatically expose the Zookeeper endpoint in order to Kafka will pick it up, because the concept of labels, the Kafka operator, like the code that will deploy this pod, Kafka pods, will figure out, okay, so let me find all pods that labeled with this Zookeeper guy and request information about these endpoints. So this endpoint will be automatically injected. So this is a thing about the network discovery and how Kafka would know where is Zookeeper, right? So in this case, all steps that happened here. So it created this resource, it was exposed, and some of the information was updated. So what we see here right now, Zookeeper now is up, and now this Kafka is coming up. So all these things, let's do get persistent volume claims. All information about storages, you see, it's automatically provisioned. So in this case, it will be using like SSD drives for Kafka, for Zookeeper. They properly labeled, so you know where you are in terms of things, and so far and so on. So it's pretty cool. So let's see, can we do something better? Monitoring, right? So monitoring. So how we can do that? There's like some generic tools like a Prometheus that can collect information. Yep. So let me start bringing this thing up. There are some generic tools that allows you to collect some metrics and expose these metrics. Like you can have a Prometheus to collect metrics and can use Grafana to display these metrics. But again, for generic tools, you just have you need to have a little bit more knowledge about like what these letters mean, what these numbers mean. You can go with the things. Thank you. You can go with the things like I know that there's certain like GMX parameters mean something, but again, for some domain-specific knowledge, you want to use a tool that allows you to have domain knowledge about what's going on here. So in this case, we have this control center tool that shows you all important things that you need to pay attention in terms of like your deployment. And also, interesting enough, you see, when I just deployed my control center, I have this pod is coming up. My Kafka still is coming up. And one of the things that I want to show you also, because I use Helm to track things or deploy things, I have information about releases. So in order to like remove things, upgrade things, I don't need to go and remove this like manually things. I can tell Helm, hey, you have a release, right? You have this information. Just go and like clean up after yourself. So if I will run this, I will see a couple of releases here. So I do have. There's my the Zookeeper. There's my Kafka. There's my C3, and I can remove like or upgrade these components independently, and just like simple as that using this standard tools. Now. So let's see what is going on here. So control center is up and running. Third container is coming up. So let's do things what it says. We can expose some of the ports inside the Kubernetes in order to see this UI. So I will do and I will do port forwarding. So I will use this this neat tool that create a tunnel between my Kubernetes cluster and my local machine in order for me to see what is going on in my cluster. So, and I will start the Google Chrome, where is it, to run this control center thingy. So, admin, fat fingers. Yep. Okay. So, in what do I see here? So in this dashboard, I'm see right now that I kind of have 3 brokers, but there's some of the brokers are in trouble. So some of the because right now I'm bringing up another broker in the third one is the last one, and the control center also should have this. It will show you the information like how many brokers was before. I will just do upgrade in a couple steps. So some of the things I can see here is also like what kind of topics I do have. I can create topic from here, so I don't need to use like any other tools and go to command line. So it's already part of this like a package that will run inside the Kubernetes. So let's see. Let's see here. So now everything established. We have a no light, no red light, so we can do some interesting things now. You see 3 Kafkas, 3 Zookeepers. Now I can use Helm to upgrade this and to scale up, but let me actually do something differently. I can use. Never do this in production. Like, okay, so you can. The cool thing about Kubernetes, you can. The tools are pretty awesome. So you can do things like this. Okay, so I need to scale up my Kafka cluster. How I can do this? I can do things like this. And I go and edit my Kafka. So now in my editor, I have my descriptor that defines my Kafka cluster. So you see, my kind is a Kafka cluster. And what I can do here, I can go ahead here and we'll do 4. So this is how I scale my Kafka cluster, and what is going on here, and 1 more pod start coming up. So we will return this by the end. I have few more slides to show. Basically what we see is the couple concepts here, is that like automated provisioning. So we just define whatever essential things we need. We need to know resources, number of nodes, and like if we want to expose it to outside world, if we want to expose it, we want to do this through using SSL and so forth, so on. We want to scale this horizontally. Like I said, you can use this Helm in order to track releases, but Helm also has a like opinionated way of doing this, so it also will shut the things up and down with this certain order. I just did this like quick and dirty with like kubectl edit. Now I can do rolling upgrade. So if I will change the image version, it will go and do rolling upgrade in specific order. So we already saw it, it flies. So yeah, it provides the automatic provisioning, scales up and down Kafka cluster, monitors with control center. We will be adding like integration with Prometheus when it will be finally released later this month. And yeah, you can run this at scale, something like this. So we can have one data center that has like data in your premises and how you are migrating to the cloud using this Kafka operator and using this replicator capability that allows to move data out of this. So don't despair. So Kafka is awesome. It's not necessarily needs to be the difficult thing. A lot of things to cover. But we got you covered, and this is you can grab this videos, some information about Helm charts, information about Kubernetes. We have awesome community in our Slack. That's it. Let me keep this. If you want to take your pictures, I will post it and tweet it, so you know where to find me. This guy. So this is me. Now, if you stay in this area until the end of the week, in our office in Palo Alto, we're doing the open house. So on Thursday, 5 p.m., you can hang out with engineers who develop Kafka, who develop Stream Platform. You can ask your questions. So this is an invitation. You're all invited. Do not forget to vote. You know that there's like 3 buttons, but most important is the green one, right? So the green one is the good button. Thank you for your time. I will be available for advanced interrogation, not right now, but like outside. I will be available for answering any type of questions. Thank you so much. You were awesome. Internet, thank you for staying with us. And thank you.